Good morning everyone. I am here to make my midterm quiz 1. The first thing that we will going to do is that we will find our RML. In our first target, we do have 095, I mean 090 degrees true bearing, which is on 800 hours. We will measure it by having our navigational instrument. Since it is on 90 degrees, so we will just measure 12 nautical miles beyond our distance scale so that we could get our R. So it's 12, and we'll put it in the center. So it's here. So our R is here. R, which is 800 hours. So that is our first target. And then for our M, in a second observation, it is on 96 degrees. So 96 degrees, it's here. It's here. So just put it in the center so that we could get it correctly. So how do we get our distance from our second observation from target 1? So since it's 10 nautical mile, we just have to adjust it to 10 nautical mile. So 96. So since it's on 96, we will put it on 96. So this is our M, which is from 806 hours. So how do we measure it? So we would measure it by having our triangle. So we would use our triangle. Make sure also that your triangle is at its right level so that you will measure it correctly. So that is our first target of our RML. And then, how do we measure our DRM? So in getting our DRM, so since we have our target 1, it is 090 degrees, 090 degrees true, and its distance is 12 nautical mile. And for its second observation, we do have 806 hour with its bearing of 96 degrees true bearing, and its distance is 10 nautical mile. So how do we get our DRM? So we will get our DRM by putting it on a center, but it is just like a parallel line to our RML. So this is our DRM. Again, measure it beyond our DRM would be, so it's it's 236 degrees. So how do we find our SRM? So in finding our SRM for this, we have to measure it by 2.5. I mean not 2.5. By measuring and measuring the SRM, we do have to get our measurement from it's just like distance times 60, which is 1 minute over 6 minutes, since we're using 6-minute rule. So how do we find our SRM? So in finding our SRM, we need to measure our RML. So it's 1 point. So we did measure our SRM distance. So it's 2 nautical miles. So our SRM is 2 nautical miles over 6, which is 6-minute rule, times 60. So if you would calculate it, so it's 2 times 60 divided by 6. That would be 4. So no, it's 2 divided 6 times 60. 2 times 60 divided by 6. That would be 20 knots. So our SRM for the first target is 20 knots. So we'll get our target B. Target 2. So in our target 2, and getting its first observation, we just have the same hours or time. So the difference is our bearing and distance. So from our target 2, we do have 270 degrees. So 270 degrees, it's here, 270, and its distance or nautical mile is 10 nautical miles. So we'll measure 10 nautical miles here. 10 nautical miles, and put it on 270. 270. So it's basically here. This is our arm. R is 800. For our target 1, this is our target 1. This is our target 2. And then the next thing that we will going to do is to find the M. So our second observation for target 2, which is on 806 hours, so it's 254, and its distance is 8 nautical mile. So how do we find 8 nautical miles? So 8 nautical mile, so here it's 8 nautical mile, and then our second observation bearing, it's 254. So where do we, so 254, so it's here, right? 254. So we'll just measure it to 254 down to the center of our radar plotting. 254. It's here. So that is our M, which is 0.8600 hours. And then we'll just measure it just like the same. So we'll just use 2 triangles so that we could fairly measure it. So here up to here, just put it just like that. So that is our second target, RM mouse. So how do we get our DRM for this? We can get our DRM by measuring it down to its parallel line, which is here. So that is our DRM. So it's 141 or 140.5. So in our target 2, our first observation, it's 0, 800, just the same, but its bearing, it's 270 degrees, and it's 10 nautical mile. And for our second bearing, it's 806 hours, 254 degrees, and then 8 nautical mile. So our DRM for this would be 140.5 degrees. So in getting our SRM is just the same, so we'll just measure it from R to M, from our RML, and then times with 60 minutes over 6 for 6-minute rule. So we'll just measure this one. So it's basically, since it's 3.7, so 3.7 nautical mile times 60 over 6. So we'll just multiply it to get our knots. So 3.7 times 60 over 6, so that would be 37 knots. 37 knots. So for our target 3, we do have our first target, we have our first observation for target 3 for 95 degrees. It's just the same, 800 hours, and its distance, it's 7 nautical mile. So it's 95. So measure it here, 95. 95 is here. This is 95. And then how do we get our distance? So our distance is 7 nautical miles. So it's here. Not 7. So 7. We'll just place it on 95. It's 95. So this is our R for 800 for target 3, and our M, it's for the second observation, it's 100 degrees from its 806 hours, 100 degrees true bearing, and its distance is 5 nautical miles. So it's just the same. So 100 is here. This is 100. And then we'll measure 5 nautical miles. So in our distance scale, 5 nautical mile from 100. Just put it here so that I'm not frustrated. So it's here. Oops. This is 5 nautical mile. So it's here. We'll just put a pen on it. So that is our M. So how do we measure it? So we'll measure it by getting it flat. So next would be get it at center. So we just have to, so we're done with our RML. So how do we get our our DRM? So we'll just have to move it to the center and put the line to its bearing. So it's 260, 264, 263, so it's 263.8. So its DRM is 263.8 degrees. And for our SRM, so we'll just measure it from our R to M. So this would be our distance scale. It's just the same, it's 2 nautical mile. So 2 nautical mile times 60 over 6 for our 6 minutes rule. That would just be the same, 20 knots. So the next thing that we were going to do is to find our CPA bearing, CPA distance, and time of CPA. So in getting our CPA, we need to put it near to our RML and then measure it like 90 degrees. So I'll just put a pencil for our CPA. So our CPA for our target 1, this is our target 1, right? So if we would measure it, so it's basically 90. So 90, it's here. So that is our CPA. How do we get our CPA? So we'll get our CPA by measuring it up to our, so it's 6.5. So our CPA is 6.5. So for our first target, our CPA is 6.5 nautical mile. So how do we get our BCPA or bearing CPA or CPA bearing? So we'll just have to prolong it. So if we would put it here, this is our CPA, right? For our first target, this is our CPA. But if you would prolong it, so it's 133. So our BCPA is 133 degrees. So that is our CPA, 133. Since it's here, 133. And then so that is our, which is 133 if we would measure it. It's 133. And for our second target, our CPA. But before we get our CPA for our second target, let's get it. It's TCPA. So TCPA, how do we get to TCPA? It's just the same. So we'll get distance divided by our SRM times 64, which is equivalent to 1 minute. So how do we get our distance for our TCPA? So we could get our TCPA by measuring its RML. So its distance is here. So it's 2 nautical mile. 2 nautical mile times 60 over SRM. What is our SRM? So it's 20 knots. So if we would calculate, it's a 2 over 20 times 60. That would be 6 minutes. So it's TCPA our TCPA is 6 minutes. Now we have our CPA. Our CPA for second target would be, since our second target is here, right? Our target 2, our measurement for it would be, since this is our second target, so our second target is here, right? We'll have to put it beside the RML, near to RML. So if this is 90, this is it's so 90, right? Near our, no, since it's near to our RML, and it's more like 90. So it's here. Here. That is our CPA. So how do we measure our CPA? So over here to here, we'll just measure it and put it on a distance scale. So our CPA would be 7.8. So our CPA for the second target is 7.8. And how could we measure our TCPA? It's just the same. It's just you have to prolong the CPA to get the CPA, since it's looking for its bearing. So our bearing is 246, since it's it exceeded 245, so it's 246. So 2 CPA, BCPA, sorry. So it's 246. Yeah, 246 degrees. And now we're looking for our TCPA. So our TCPA is distance divided by SRM times 60. So how do we get our distance? So it's just the same with our RM. So if we would measure our RM from our target 2, so it's So it's 3.7. So 3.7 nautical mile over 37 knots times 60. So 3.7 divided by 37 times 60, which is 1 minute. So it's 6. That's 6 minutes. So let's just repeat it. 3.7 divided by 37 times 60, so it's 6. It's just the same, so it's TCPA is 6 minutes. This is my own observation when I tried to measure it. So for our target 3, our third target, our CPA would be here. So this is our target. So we'll get our here. So that is our, here, since it's 30. It's 90 degrees. Sorry. So it's here. This is our CPA for our target 3. Right? So we would measure it. So if we would measure it, we'll get 1.5. So our CPA is 1.5 nautical miles. So how do we get our BCPA? It's just bearing. So we'll just have to prolong it or continue its line. So it's here. So it's 165. 165.9. So it's just near. So we'll just have to put it 165 degrees. And our TCPA, the last one, so we have to calculate distance over SRM times 60. So it's just basically distance. So what is our distance? Since we do have the 2 nautical miles, so we'll just have to measure it again so that we could assure that it's 2 nautical miles. 2 nautical mile. Yeah, 2 nautical miles. So it's 2 nautical mile over 20 knots times 60. So we'll get TCPA. So since we do have the same, so we'll get also 6 minutes. So therefore, that is our calculation for our observation right now. So that would be all for now. Thank you.